Unit 6, Day 6, trapezoid proofs. Before we begin the proof, let's talk about properties of a trapezoid. As you can see, there are only two properties of a trapezoid. Number one, a trapezoid has exactly one pair of parallel sides. And that word exactly is important. That means one and only one. One pair of sides will be parallel, one pair will not be. We have to prove both. And then the second property we don't use in the proof, but it is a property of a trapezoid. We say that same side interior angles add to 180 degrees. And I'm not going to talk too much about that today. As I said, we're going to do the proof part of this, but when we review for the final exam, we'll talk about that again. So how do we prove a trapezoid? This is the part that's a little bit different than all of the shapes we've done so far. We have to use four slopes. There is only one way to prove sides or lines are parallel, and that is to use slopes. We don't have the option of using distance here. We are going to use four slopes to prove exactly one pair of parallel sides. Before we move on to the proof, I need to talk about slope. The slope formula, if you guys remember, if you want to use coordinates, it's y2 minus y1 over x2 minus x1. So like the other proofs that we've done, you'll be able to use coordinates if you choose. Or you can think of slope as rise over run, which is what I do. I prefer to be visual, and I just count the rise and I count the run, and it's much quicker for me. But if we use rise over run, we have to remember four scenarios. All right, here's the one scenario. If your slope goes uphill, that means it's got to be positive. So you have to remember to put that in there, or you just leave it. If your slope goes downhill, this is the tricky one. It's negative. So a lot of times we count the rise over run and say, oh, it's down 2 over 5, it's 2/5. And it's negative 2/5 because you have to go down. And then there are two other special cases. The first one is if your line is completely vertical, we say the slope is undefined. We abbreviate undefined with UND. Sometimes you'll see no slope. And then the last one is if your line is perfectly horizontal, the slope is 0. So these two we'll see from time to time. Those are challenging. Remember, it's totally vertical, it's undefined. Horizontal, 0. Now this won't take long at all. Right? These two examples will take minutes. Prove ABCD is a trapezoid if, and then they give you the coordinates. They also give you the picture. Well, I prefer to use the picture, be visual, and here's what I like to do first. Just looking at the figure, can you see what sides are parallel? To me, it looks like DC is parallel to AB. So I'm going to find those two slopes first. I use M for slope. DC's, I'm finding the slope of that side. Well, like we did with distance, I'm going to make a little triangle like so and count 1, 2, 3 here and 1, 2, 3 there. So the rise is 3. The run is 3, and because it's going uphill, it's positive. So I can leave it like that, or you can simplify 3 over 3 to 1, which is probably what we are going to do because we need to compare it to another side. Now we'll find the slope of AB. Well, again, we do something similar to what we did before. We count the rise, 1, 2, 3, 4, 5, 6. We count the run, 1, 2, 3, 4, 5, 6. So it's 6 over 6, which is obviously 1. Now, I'm not going to say that those two are equal because they are different lengths, but since their slopes are equal, I can say that they're parallel. DC is parallel to AB, and that's the symbol for parallel. Now that we got two sides that are parallel, we have to show that the other sides are not parallel because we need exactly one pair. So it's not enough just to show those are parallel. Now we need to go on and say, all right, well, let's find the slope of the other two sides. Slope of AD. Well, the slope of AD, that's a completely vertical line. We said from up above, that slope is undefined. So there's really not a whole lot we do there. Now I find the slope of CB. Well, the rise is your delta y, that's 2. The run is your delta x, that's 3. But notice here, we went downhill. So that means that slope is negative, negative 2 over 3. Okay, so now we compare AD and CB's slopes. We see that they're different. Well, if the slopes are different, that means they are not going to be parallel. So we say AD is not parallel to CB. So what we've just shown here is that we have one pair of parallel sides and one pair of sides that's not parallel. And that's exactly the definition of a trapezoid. So now I can say ABCD is a trapezoid because it has exactly, we have to include that word, one pair of parallel sides. Example 2, our last example. Again, I want to prove that this is a trapezoid. You are given the coordinates. You're also given the picture. Looks like to me that side AB is parallel to side DC, so I will find those slopes first. Slope of AB. Rise over run. So the rise is 1, the run is 1, 2, 3, 4. So that slope is 1 over 4. It's going uphill, so it's positive. I'll just leave it 1 over 4. And now I'm going to find the slope of DC. The rise is 2. The run is 1, 2, 3, 4, 5, 6, 7, 8. So 2 over 8, which simplifies to 1 over 4. From last unit again, we said if the slopes are equal, the lines are parallel. So I know AB is parallel to DC. And now we need to find the slope of the other two. They'll be different, so those sides are not parallel. You know they're not parallel by looking at it, but remember this is a proof, so we have to show it. Slope of AD, another vertical line, so that slope is undefined. The slope of BC. Let's see, rise over run. My rise is 2, my run is 4, 2 over 4, but remember it's going downhill. Downhill, so it's negative. You can simplify that if you want, but because I know it's different than undefined, it's not necessary. Those two slopes are not equal, therefore AD is not parallel to BC. And that is enough to prove that this is a trapezoid. ABCD is a trapezoid because it has exactly one pair of parallel sides. And that's how you prove a trapezoid. And that concludes this lesson.